chord. Okay. Let's take an angle. Pick an angle between, I don't know, 0 and 90 degrees. Go ahead, somebody choose one.
55.
What is it, 35?
55.
55. So let's see what 55 is. I'm a little bit crooked on mine already. Let's see. Yeah, close enough. This is the 55 in this direction. Can you see it on the screen? Oh, that's 50. Sorry. 55 is somewhere halfway between 50 and 60. I can't really tell. It's right there. Can you see that, the 55? So that 55 angle, that little mess up there bothers me. Let me draw a line now from the center. And I can go as far as I want to. The length of that is not important. So I can go as far as we want to. This is the 55 degree. Now keep in mind, I'm not really 100% accurate, so that's about right there. So my number should be very close to the neighborhood. If you want to find the sine, cosine, tangent, secant, cosecant, cotangent, the way we do it, we make a line parallel to this. We have to make a triangle. Right? Is that looks like close enough to it? Something like this. There's my triangle. This side here is known as what? We have names to these sides. This is the hypotenuse.
A and B.
This is the adjacent. And this is the opposite. I'll come back to the 55 degree in a minute. But the sine of any angle, the sine of theta, theta could be any angle, is the ratio of what sides? Opposite and the hypotenuse. The cosine is what? Adjacent over the hypotenuse. Sound like a baby in the classroom. The tangent. Opposite over adjacent. So let's see if this is true. So we're talking about the 55. What is the sine of 55 degrees? According to my equation here, let's measure the length of this side. Let's measure the length of this side and divide them and see if that's the answer. So here's my ruler there. You can use centimeters. It's hard to see with this. Let me get another clean one. I like this chair. Run back and forth. There we go. Let's measure the length of this. The opposite. What do you think that value? 6 point what? Maybe 2 or 3, somewhere there, right? Around 6.2, 6.3. I don't know if you can see it. So I'll say 6.3 over the hypotenuse. That's from this dot to the center. Let's measure it. What do we get? Almost 8? Is that 8?
Yes.
Let's see what that number is. Where's my... Let me divide the two numbers. 6.3 divided by 8. 0.7875. Let me find the cosine of 55 degrees. Cosine is the adjacent. So let me measure the length of the adjacent side. And I'm getting roughly 4.5, right? So it's 4.5 divided by the hypotenuse, which we know that's 8. We just measure that. 4.5 divided by 8. 0.5625. And what is the tangent of 55 degrees? It's the opposite, which is this side, and that's 6.3, over the adjacent, which is this side, and that's what, 4.5? So 6.3 divided by 4.5, it's 1.4 approximately. So if we were close enough, we should be in the neighborhood of the correct answer. Let's see actually if I go to my calculator and ask the calculator to give me what is sine 55, and what's cosine 55, and what's tangent 55. First thing first, since I'm using degrees, I need to make sure I'm in degree mode. So I'm going to go to mode and make sure I'm in degree, and thank goodness, because I was in radian. Now I'm in degree mode. Hit enter. So I just change it to a degree mode. So let's find the sine of 55. Now again, when we did this, it's 0.7875. Let's see what the answer is. 0.819. Not that far. If you round this, that's 0.79, 0.82. As I said, I wasn't sure, is it 6.3, 6.4, 1 millimeter will make a difference. Let's try the cosine. The cosine of 55. I said 0.57, 0.562. Right close to it. Let's try the tangent. The tangent, where's the tangent here? Of 55. When I did it on the graph, is about 1.4 in that neighborhood. 1.42. So this stuff works. Notice I didn't say how far to go, so just make a triangle. Just make sure that angle is 90 degrees. I never check to see if that angle is 90, because if it's not, if it's crooked, we're in trouble there. Let's see if it's 90 degrees. And what do you know? I'm a little bit off. Not a lot, by about a degree or two. I'm not really 90 on the money, I'm a little bit off. So if I move this closer, if I made 90 degrees and drew it there, I'll move a little bit closer, and that will change a few answers, millimeters. But that's what the definition of sine, cosine, and tangent. Opposite over hypotenuse, again, we have a saying, and that's Sakatoa. That Indian chief. S for sine, opposite over hypotenuse. C for cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So that's how most people remember that Sakatoa. There's also 3 other trig functions that you do not see on your calculator. And what are they? So I'll go on the next page, continue with it. We have the secant. We have the cosecant and the cotangent. Those are not on your calculator. You can look at yours, mine. I have a nice one. Look at it. You won't see them there. So we should be able to find out what these values are. We have to remember that the secant is equal to what? 1 over the cosine. So since the cosine is the adjacent over the hypotenuse, that means the secant is what? The hypotenuse over what? Adjacent. That's dead there. Cosecant is what? 1 over sine theta. So the sine theta is what? Opposite over hypotenuse. That means the cosecant is what? Hypotenuse over opposite. Notice when you look at the triangle, what is the longest side here? Hypotenuse. So the sine is always going to be less than or equal to 1. The cosine is always going to be less than or equal to 1. These, the smallest value is 1. It's 1 or larger because it's this side over that, and this is the longest side. So these two here, the answer is always 1 or higher. They'll never be less than 1. And the cotangent, which is what? 1 over tangent. And that's what? Opposite over the adjacent. I also did not mention that the tangent, you can take the tangent by finding the sine and dividing it by the cosine. That comes in handy a lot today. So the cotangent is going to be what? The cosine over what? The sine.
The cotangent,
Cotangent, yep.
yeah, it wouldn't be the opposite?
Opposite to what?
Tangent.
It's the reciprocal.
Over the opposite.
What did I write? Oh, the adjacent over opposite. Yes, thank you. As you flip that one.
Yeah.
Good eyes. It's the reciprocal of this. So whatever this, you gotta flip it. It's the opposite to the reciprocal. It's not opposite. The reciprocal of this. Adjacent over the opposite. Reciprocal means flip it. All these are the reciprocal of these. You flip them. Notice the sine over cosine, you flip it, it becomes what? Cosine over sine. So if I come to you and I say, okay, you can use your calculator, go ahead, tell me what is cosecant 33 degrees. You go, oh, cosecant, where's my button on the calculator? Where's that cosecant button? Let me look. It's not here. So what do you do now? Cosecant is what? 1 over sine 33 degrees. If you have one of those small calculators, you got to do this one probably first, then do 1 over that. You can't do both in one shot. If you got the ones for like $5, $3. But most scientific calculators, you can type the whole thing in one shot. $1.836. Plus more digits, but that's plenty. If I said, what is cotangent? Pi over 4. Notice what mode I am here. Radian. So I will go to mode first, change the mode. Mode, go back to radian. Get out of it. Now it's 1 over tangent pi over 4. So let me type it in. 1 divided by tangent, and I write pi divided by 4 and close the parentheses. One divided by tangent pi over 4. Hit enter. What do you know? It's 1. That's a 1. Secant 2 pi over 3. Since I'm in radian, I'll stay there. Secant is what? 1 over cosine 2 pi over 3. So So let me find that. 1 divided by cosine parentheses 2 pi divided by 3. Negative 2. So we can find the sine, cosine, tangent of any secant, cosecant, cotangent of any angle, degrees or radian, if you have a scientific calculator or you have a unit circle. Unit circle is only helpful if we give you one of those, angles. If I give you a different angle, it doesn't do me any good. So there's the first set of identities we need to know. If I was to number them, I go, this is number 1, number 2, number 3. The tangent is the sine over the cosine 2. Number 4, number 5, and number 6. They are on the board. Can you see them? First 6. I call the opposite side. You notice on the board I'm using x and y. If I call this y, and I call this side x, and I call this one r, then the sign will be what? Y divided by r. The cosine is x divided by r. The tangent y over x. Now, if you have your calculator handy, leave it out there. Pick an angle, any angle you want. Don't tell me what that angle. If you take the sine of that angle and you square it, add to it the cosine of that angle after you square it, what's the result? 1. Always 1. When you see this, by the way, this one means sine of theta, the whole thing squared, plus cosine theta. That's what that means. So somebody pick an angle, any angle you want. It doesn't matter if I'm in degree or radian. Don't even worry about it. Pick any number. What is it?
70.
70. Let's try that. Sine of 70, and let me square it, plus the cosine, I need to use brackets here, parentheses, the cosine of 70, square that, square it. So if I type this correctly, my answer should be what? 1. Let's see, enter. 1. I'll pick a different one. The sine of negative 12.3 squared plus the cosine of the same angle, has to be the same angle, negative 12.3 squared, better be 1, 2. Doesn't matter what we use. This is one of those basic trig identities. Sine squared plus cosine squared is always equal to 1. Always. If you want to know why, really the answer to that, I just thought of it. If you want to know why, go back to this. If you go back to this triangle, let me label the triangle again. R, Y, and X, right? Here's the reason why. There's my triangle. This is what? R, this is Y, and this is X, right? The sine is what side? Opposite over the hypotenuse. This is theta. So the sine is Y over R. I need to square it. The cosine is what? Adjacent over the hypotenuse. Let's do the math and see what is that equal to. Well, if you do the math, what do you have? Y squared over what? R squared plus x squared over r squared. Notice I'm adding two fractions. The bottom is the same. Keep it. How is that 1? It's supposed to be 1. How is that equal to 1? Huh? Let's go back to Pythagorean theorem. Remember Pythagorean theorem? C squared equals what? A squared plus B squared. Let's put our letters there. C here is what? R, so that's R squared. A is what? X squared. And B is what? So x squared plus y squared is equal to what? R squared. Come back and plug it in here. What's x squared plus y squared? R squared. What's r squared over r squared? That's the 1. That's why any angle, the sine squared plus the cosine squared is always equal to 1. And there's the math to prove it. I have this identity written on the board, sine squared plus cosine squared equals to 1. That's number 7. Then I get 2 more under it. Like, where are they coming from? So let me derive the other ones that you see there. Let me write this one first. I'm going to play with this now, since I'm having fun. Hopefully you're having fun. What will happen if I move the cosine squared to that side? What would you have? You'll have sine squared theta equals what? 1 minus cosine squared theta. That's on the board, number 10. Let's look at this one again. Instead of moving the cosine, what about if I move the sine to that side? What would you have? You have cosine squared theta equals what? 1 minus sine squared theta. That's also on the board, number 11. They look like different equation, but it's really going back to this one. Just a little derivation out of this one. Let me try again, another one. Sine squared theta plus cosine squared theta is equal to what? 1. This is an equation. I can divide every single term by the same thing without changing the equation. I'm feeling like dividing by sine squared. Don't ask me why, just that's the feeling I want. What is sine squared over sine squared? 1. What's cosine squared over sine squared? That's a cotangent squared. Because cosine over sine is cotangent. And what is 1 over sine? Isn't that cosecant? I think I have that on the board. That's number 8. So 7, 8, 9, 10, 11 on the board, they're all coming from the same equation. Now again, as I said, I'm feeling like dividing by sine squared. What about if I felt like dividing by cosine squared? I go, I don't like that feeling. Let me divide by cosine squared. Sine over cosine is what? Tangent. This will be a tangent squared. Cosine over cosine, 1. 1 over cosine is what? Secant squared theta. And I have that on the board too. Number 9. So it looks like that all these equations, it's really one equation, we just derived stuff out of it. I can even derive more. Notice if I move the tangent to this side, I'll have 1 equals secant squared minus tangent squared. I can go crazy with it. I can move the 1 here, make it tangent squared equals secant squared minus 1. I can derive 10, 12 equations out of this sine squared plus cosine squared equals to 1. So when you look at our book there, they give you a list of equations and go, where are they coming from? Just playing with the algebra. Here's what our book did. They gave us the basic ones. Move the light a little bit off. Can't zoom in on it because I'm recording now. But the first one says, we know the cosecant is 1 over sine, right? You can also say that sine equals 1 over cosecant. It's back and forth. We know the cosecant is 1 over cosine, which means the cosine is 1 over cosecant. We know the cotangent is what? 1 over tangent? That means tangent is 1 over cotangent. Tangent is sine over cosine. Cotangent, cosine over sine. Here's the other ones. Sine squared plus cosine squared equals to 1. 1 plus tangent squared equals to 1. Secant squared. I just derived that one 2 minutes ago. And so is this one. Both of these we just finished deriving right here. 1 plus cotangent squared equals cosecant squared. And the last one, tangent squared plus 1 equals secant squared. Doesn't matter which one you write first. So that's where they're coming from. Okay, why do we have to know this stuff? Here's the answer. Let's say I go to this problem, which you're going to see for homework. Simplify. Simplify what? Let's begin with tangent theta times cosecant theta. I want you to simplify that and tell me what the answer is. You can look at the board since my sheet's gone here. The key to that is, I find the easiest thing to do really is write everything in terms of sine, cosine, because we can't memorize all the rules. Yes? Could be. Could be. Let's see. When I make these, by the way, I don't know what the answer is, honestly. I just make them. So let's see. What's tangent equal to? Sine over cosine. So let me rewrite everything in terms of sine, cosine. And what's the cosecant? 1 over sine. Can you cancel anything? So what's left? 1 over cosine. And what's 1 over cosine? Secant theta. So this is equal to secant theta. That's what you're going to be given for homework. Except we make them a little bit bigger. Let's try this one. Simplify. Secant squared y over cotangent y minus tangent cube y. Again, I'm always going to try to write everything in terms of sine, cosine, because I'm not going to memorize the bottom ones. Secant is what? 1 over cosine? But that's squared, so it'll be 1 over cosine squared y. Divided by the cotangent, which is what? What's the cotangent? Isn't that cosine over sine? Okay, what should we do here? What do you think? Any suggestion? What do you want to do? Well, let's simplify this fraction first.
Over y.
Can I simplify this fraction?
Yes, sin y over.
Yep, outside over the inside, right?
Yeah.
So it's this times this
Yeah.
over this times this. So it's going to be sine of y over cosine cube y. I'll leave the tangent cube for now. I'll fix that later. Sine over cosine. Well, I can rewrite this as what? Or I can take this, go, you know what? This is sine of y over cosine cube y. And let me change the tangent to what? Sine cube y, because that's a cube, right? Over cosine cube y. Notice these two are the same. That's sine of y minus sine cube y over what? Cosine cube y. Anything else I can do? Can I factor a sine y out of the top? Let me factor sine y out of the top. What's left? 1 minus sine squared y. Now, can you look at the board? Equation number 11. What do you see written there? I see this as cosine squared theta equals what? 1 minus sine squared theta. You see it on the board, number 11. So if I plug that here, I'm going to have sine of y. In place of 1 minus sine squared, I'm going to have what? Cosine squared y over cosine cube y. You get 2 cosines on the top, you get how many on the bottom? 3, right? So 2 of these will cancel 2 of these. What's left? 1 sine on the top and 1 cosine on the bottom. And what's sine over cosine? Tangent y. Bend, twist, fold at the end, they all fall in place. It's like playing with Play-Dohs there. So the answer is tangent y for that one. Let's try a few more. Simplify. Cosecant x over what? Tangent x plus cotangent x. Again, I'm always going to try by changing everything to sine, cosine. Cosecant is what? 1 over sine of x. Tangent. What's a tangent? Sine of x over what? Cosine x plus cotangent, which is what? Cosine x over what? Sine of x. Let's look at the bottom, just the bottom fraction. Leave the top alone for now. I'm not interested in it yet. If I look at the bottom, you adding two fractions. Well, if you want to add the two fractions, what do you need?
Common denominator.
Which is what in this case?
Cosine of x multiplied by sine of
Yep,
x.
this times that. So I'm going to rewrite each fraction to have cosine x, sine x. Now let's look at this fraction, that fraction. What's missing from it? What's not here that you see here? Sine, right? So you're going to multiply the bottom of this by sine of x. That means you're going to multiply the top by sine of x. What is sine of x times sine of x?
Sine squared x.
Sine squared x. Again, let's look here and there. I'm missing the cosine. Let me multiply the top and the bottom by cosine to match this one. What's cosine times cosine? Cosine squared x. I can rewrite that. Again, here we go. Leave the top alone. I'm ignoring it for now. The bottom is going to be sine squared x plus cosine squared x over what? Cosine x, sine x. Identity number 7 on the board. It says what? I'll put it here. Sine squared theta plus cosine squared theta is equal to what? Equals to 1. Use that here, right there. So this becomes 1 over sine of x over 1 over sine x cosine x. Outside over the inside. When you have a complex fraction, multiply the outside over the inside. 1 times this is what? Sine of x, cosine of x, over the inside. The inside, what's sine of x times 1? And what do you notice about the cosine? They're gone. And what's my final answer? cosine of x. Isn't this fun? Try a couple more, maybe one or two more. Then I'll leave the rest for you to have fun with them when you go home. Let's try another one. Let's see. Simplified. Cotangent theta, I'll use theta here, secant squared theta minus 1 over tangent theta. Again, I have no idea what the solution to these is, so we're going to go through it. Cotangent, what is that? Cosine theta over what? Sine theta. Times secant. Secant is what? 1 over cosine, but that's a squared. 1 over cosine squared theta. Isn't 1 over tangent cotangent? Right? Cotangent is 1 over tangent. I'm going to change it to cosine over sine in a second. So here's, this cosine is going to cancel one of these cosine. You see that? There's a cosine here and there's two of them here.
Yeah.
So what's left? 1 over sine theta cosine theta. Minus the cotangent, which is what? Cosine theta over sine theta. Again, I'm going to add or subtract. I need an LCD. So I need the bottom to be the same. There's no change to this. I'm not changing this, so it stays 1. This one I will have to multiply by
Cosine?
cosine. Multiply the top by cosine. Sine theta, cosine theta, that's the bottom. The top 1 minus cosine squared theta. Again, I'm seeing on the board number 10, it says what? Sine squared theta equals 1 minus cosine squared theta. So the top will be sine squared now. There's two of them, there's one of them here. This one of the sines will disappear, so you end up with what? Sine theta over cosine theta, which is what? Tangent theta. Okay, so that's the simplifying portion of it. I'll leave the rest for you to have fun with. If you have any questions, bring them next time.